You flip a coin twice, keeping track of the number of heads you get. Is this a binomial distribution? Well, first, let's think about all the possible outcomes for this situation. This is going to be the sample space. Now you're flipping it twice. You could get two heads in a row. We'll represent that with HH. That's heads on the first flip, heads on the second flip. So the first letter is the first flip, and the second letter is the second flip. You could get a heads and then a tails. You could get a tails and then a head. And the only other possibility is two tails in a row. So here's all the possible outcomes. Now we're keeping track of the number of heads we get. So there's going to be three possibilities for the random variable. We could get 0 heads, 1 head, or both of the flips be heads. Now the probability of getting 0 heads is only the tail-tail case, which is 1 out of 4. So 1/4 probability. The probability of getting 1 head, well, there's 2 possibilities of getting exactly 1 head. That's 2 out of 4, or reduce that to 1/2. And then the probability of getting exactly 2 heads is just the HH case, which is 1 out of 4. Now, is this a binomial distribution? We have to see if it follows these 4 requirements. The first requirement is the number of trials. Are they fixed? A trial would be a flip. And yeah, it's fixed at 2 flips. So, check. The second requirement is each trial independent. Yeah, when I do the second flip, it doesn't matter what the first flip was. So the second flip is independent. So each trial is independent. Check. The third requirement is each trial a success or failure. The success being a heads, a failure being not a head. So yeah, each flip is either a success or failure, either a head or not a head. Check. And then the fourth requirement, the probability of success needs to be the same for each trial. And yeah, for each flip, the probability of getting ahead is 50%, 1/2. So, check. So this scenario satisfies all 4 requirements to be a binomial distribution.